Hello class, what we're going to talk about in this video is theoretical probability versus experimental probability. Now, the last video we did all kinds of probability stuff. That is all theoretical probability, okay? And we had this definition talking about theoretical probability. What are the odds of something happening from 0% to 100%, right? And we found out by the number of favorable outcomes over the total number of outcomes. Experimental probability is very, very similar. This is theoretical. We haven't actually done it. What is the probability of getting heads on a coin flip? 1 out of 2, right? Until you actually flip the coin. Once you actually flip the coin, well, if I've only flipped it once, maybe it wasn't 50%, right? How could it be 50%? I've only flipped it one time, right? So experimental probability, it is number of favorable outcomes over the total number of trials, okay? So if you flip it 5 times and you get 3 heads, it would be 3 out of 5, okay? So it's very, very similar, only instead of being over total number of possible outcomes, it's over the total number of trials. How many times did you run the experiment, okay? And speaking of that, I have a little program here on my calculator that is going to simulate a coin flip. All right, you'll have heads on the left, tails on the right, and so here it goes. And you see on this one, it's flipping heads a lot more than it's flipping tails. However, notice that the more that this happens, the more coin flips it simulates, the closer they get, right? The closer it gets to that 50-50 of the theoretical probability. So here it's gone almost 70, and we've got about 58% of it has been heads. 45, 44, 43 for tails. And the longer you let this run, the more experiments you do, the closer and closer it will get to that theoretical probability. And so I'm just going to let this run in the background for now. We'll take a look at that again later on, see how close it got. So looking at this, we've got a spinner here, right? And if you spin that spinner, you should have a 1 in 4 shot of landing on yellow, right? So that is in theory, right? You've got 1 yellow out of 4 total colors. The spinner's flat, so it's all even, right? So they actually spun this 20 times, and yellow didn't come out 1 out of 4, right? That's the experiment. So the probability of this is the number of times it came up that color over the number of times you actually spun it. Okay. The question is, which one has the same experimental probability as theoretical? So looking at this, the probability of red, there are 5 red results, which are what we're looking for, over 20 total trials, 20 total attempts. Okay. So that's 5 out of 20, which is 1/4. Probability of green is, we'll see, we had 9 green results, 9 favorable, over 20 total trials, and so that's 9 out of 20, which doesn't simplify, so it's just not 20. Probability of blue is 3 out of 20. Probability of yellow is also 3 out of 20. So which one of these had the same probability experimentally as it did theoretically? And that would be red, because it came out as 1/4, which is the same as the theoretical probability. All right. So you see, the probability experimentally is never going to be the same, or very rarely going to be the same as the theoretical. It'll happen. Here it happens, right? Every now and then, if you flip a coin, you'll get heads one time and tails the next, but not usually, right? Usually it's heads, heads, then tails, 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 heads, heads, tails, tails, right? Back and forth. So you don't really know until you do the experiment. But the more you do it, the closer it gets. Here we have a survey done in the United States. They surveyed 2,184 adults over the age of 18, and they found out that 1,328 of them have at least one pet. Here's the types of pets that they said that they had. What is the probability that of the pet-owning adults chosen at random, they will have a dog? Okay. Now, we got lots of information here, but we are only pointing at, we're only looking at the adults who have pets, right? And so we're just looking at the 1,328 of them. So, of that many adults, how many of them have a dog? 916. So we have 916 that are favorable, that have a dog, have the result we're looking for, out of the trials of 1328. So 916 over 1328, you can simplify it as a fraction, or you just change it to a decimal. All right, which gives us about 69% of pet-owning adults have dogs in the United States. All right, so you see how this works? This is good because experimental, you can do things that theoretically, how many people have a probability of picking someone with a dog? No clue, right? You got to actually do the experiment to come up with that. So this is where experimental is more useful than theoretical. So what I want you to do, in example 5, for which color is the experimental probability of stopping on that color greater than theoretical probability? For which one is it? Then for number 6, what's the probability of choosing somebody who owns a pet and has a fish? All right. Pause the video, look at these, then come back and check your work. All right, so number 10, green. We already saw that before. Green was 9 out of 20, which is greater than 1/4. For number 11, it's about 11%. So for the fish, that's 146 out of the 1328 that had pets, because it's just pet-owning adults, not all adults in the survey. And so there's your percent there. Real quick, let's take a look at that experiment we had. So we're up to almost 900, we're at 860, 70. And so, and you see, notice it is very close now to the 50%. Very close to that theoretical probability. So, experimental probability versus theoretical. Experimental, you actually have to do it. Theoretical is just thinking about it, okay, what should it be in theory? And so, theoretical probability, it's total favorable over total possible outcomes. Experimental probability, it is total favorable over total number of trials. How many times did you test it? Okay, and the longer you go, the more tests you get, the closer it will be. Hopefully that helps, and I'll see you next time.